we're going to start with our next lecture now, in which MacLemon is going to talk to us about email and how does it even work.
Hi, thanks for your resilience and bearing with me through maybe another talk. I'm still MacLemon. I'm still available on the Fediverse, on Mastodon, and somewhere on the interwebs if you want to find me. And this is about email. Let's start with a brief history, very brief history. In the early 60s, mainframes were common. Mainframes are like a large room with a single computer in them, because computers were larger back then. And stupid, simple terminals that were connected to it so people could interact with that computer. And of course, humans being humans, they had the idea, well, we could send each other messages using that computer. So they started putting files into each other's home directories because the username was unique on that machine. And so we already had a messaging system that was multi-user, but on a single host, at least. That was the 60s. In 1969, they started to be more formal, like having like message transactions. There were two commands back then on the mainframes. They were called message send and read mail, like very simple things. But they could already transfer messages between two computers. So now we're multi-user, multi-host, or certain definition of multi. Then in 1970, the universe began. Now we have a time frame, a timeline. We start at 0, of course. Before there was no time. And in 1971, Ray Tomlinson said, well, now we're having usernames and we need to somehow designate on which host that user will receive the message. So we need some character to delimit between the username and the host name. And so he said, well, I need some character to do that. And this one was available. It was not in use anywhere else. And that in English it's called the @ sign, was purely by accident. So they used it and it was fine. So email addresses or message addresses looked like Ray at 10xa. 10x was a popular operating system back in the day. And why does that hostname look like that? Because DNS will be invented in the 80s. So in about 10 years. And they were passing hosts files back and forth, the world file, which contained all the known host name IPs and names, and they were passing that around. Mail was not, DNS was not invented yet. In 1973, people started formalizing message headers, so they were easier to pass around. It became an RFC standard by then. In 1975, the message transmission protocol, not so simple yet, was invented to have some formal way of passing messages around. And also the first message groups, probably what we call emailing lists, appeared. And then even a standard for the format of the ARPA network text message was made an RFC. And now we have pretty much everything we need for something like an email system. We have a header format for addressing. We have a protocol for message transport. And we have a message format. So, yay, email. We're done. Okay. It's a little more complicated than that, I admit. Of course, these RFC were worked over and made a little better and improved. And in the 80s, yeehaw, this is what started it all. It's probably what the thing that's most closely already to what we use with email today. Started with RFC 821, which is SMTP, the Simple Message Transfer Protocol, and RFC 822, the message format. Okay, no. I won't want to bother you with what was the single charts back then. You may remember and it will hurt. So who of you still uses this email thing? Is that anyone? Okay, that's about 97%. And a few shy people who don't dare to admit it. That would be me. Yeah, so how does email work today, around 2018? Well, that's it. That's email. You have a phone, you have another phone, and between there's magic, and you get an email. And that's pretty much it, isn't it? Oh, another one. Damn. Okay, it's a little more than that, I guess. So let's get ourselves a small recap of the terminology so that everybody knows what we're talking about. We do have an author. She's on the left on the slide. We do have a recipient. Let's call them author and recipient. That would be convenient, probably. And that author is using an email application, or in email terms, that is called a mail user agent. Your standard mail application like Mutt or Mail App or Outlook or Thunderbird or whatever you use. And yeah, our author has an MUA, a mail user agent. And since it's the authoring mail user agent, we call it the authoring mail user agent. It's pretty simple, that concept, you get it. So when that author wants to send a message, she needs her mail application to talk to something, and that is called the mail submission agent. It's nothing to do with submitting email messages, not even if you're running OpenBDSM as an operating system, but the mail submission agent accepts emails from clients, so that is that connection. And once the mail submission agent has accepted the message, it hands it over to a mail transport agent, commonly referred to as mail server. And since it's the one of our sender, our author, it's a sending mail transport agent, so we're here. And then that sending mail transport agent wants to pass that message over the internet to somewhere else, probably, hopefully, the receiver. There may be one or more relaying transport agents in between, but we'll pretty much ignore that because they don't add a lot to the concept. And at some point, hopefully, that message arrives at the receiving mail transport agent, which is here. And that transport agent now thinks, well, what do I do with that message? Where's my recipient? Can we deliver that somewhere? Oh, there's a delivery agent. How convenient. Let's pass the message on to our mail delivery agent. That would be probably your Dovecot or Cyrus or whatever you may be using. So we're here. There's no bad jokes with MDMA here. And our receiving mail user agent, our recipient, she is using her application to collect the emails. And you already see our parts are interconnected, and each of the connections, each of these pairings symbolizes something where things communicate with each other, and to communicate, these things need a common language so they understand each other, and this is what we call protocols. So far, so easy. So let's see how these things talk with each other. There's our authoring mail user agent, our mail submission agent, commonly referred to as sending email. Quite boring. That's this part in the picture. And a common misconception is that mail user agent and submission agents talk SMTP. They don't. They use something called message submission. It looks a lot like SMTP. Many things look like SMTP in email, but there's a few very minor changes to it. What does the communication look like? It's way too small to read, so don't even try. I'll give you a brief overview. The client connects to the mail submission server. Server says, hello. Client says, well, hello. And then the client says, well, let's start encryption. Isn't that a good idea? Server says, well, okay, let's do that. And they do a TLS handshake, and this is what the communication looks from then on. Okay, oh, yeah. Since we're the user agent, we already have the keys because we did the handshake, so this is what it looks like. Server says, well, who are you? Are you allowed to do this? May I see your password, please? User agent sends authentication credentials. Server checks it, thinks, looks plausible enough. I'll let them pass. And then the mail client starts sending email by passing on a recipient and all the data, a few headers. And then when it's done, it says, single dot as the first character on the line. Server says, okay, I've queued that message, and they say bye. Very friendly conversation. Quite easy. So that's pretty much it. That mail submission agent has put that message into the so-called incoming queue, because there may be multiple messages coming in at the same time, and they're just lining up like you do at the bar. And the message submission agent says, well, I'll hand it over to some transport because I'm just here for accepting them from clients. Let somebody else do the rest of the work. So they hand it over to the transport agent. That's usually something quite local to the server, and the transport agent takes the message, cleans it up a little bit, checks if it's a local delivery or if it has to pass it on over the internet. For this example, we'll pass it over the internet to somebody else, and so this sending mail transport agent will try to pass the message to the receiving mail transport agent. That's this part of the scheme. We'll ignore the intermediate mail transport agents because it's just the same over and over again, so we'll simplify. That's look a lot more friendly now. Even the slide is smiling. And now we're actually talking SMTP, the RFC 5321. So what does that look like? And where does my mail transport agent actually know which other mail server to contact? Any ideas? MX record, yes. It's consulting DNS and asking, so I've got email for that domain. Do you know any mail servers I could talk to? So it looks up the MX record, which is short for mail exchanger. You can easily check that from the comfort of your command line by issuing a host-t for an MX command for the domain, and hopefully DNS will tell you whom to talk to, which is in our case mail.balkan.org. Simple enough. So mail server starts talking to another transport mail server. They say, hello, I'm here. The other one, oh, hello, I'm this. And then the receiving mail server says, well, I can do this kind of things. And I say, oh, okay, that's nice. But the rest of the conversation is pretty much the same as we already saw. They pass on a recipient, they pass on message headers, the message itself, and when they're done, they finish with a single dot as the first character on a line and the return, and then they say bye, everything's fine. Message queued, and the receiving mail server has accepted that message for transport. Since mail transport agents want to get rid of messages as soon as they can, usually, they want, okay, this is for delivery now. Where's my delivery agent? It's pretty much local, that's handy. And it tries to pass that message on to the mail delivery agent. And these two are speaking another protocol. It's called LMTP, the Local Message Transport Protocol. And as you've guessed it by now, it pretty much looks almost like SMTP. So they did not reinvent the wheel, they just changed a few things again to make it easier. And that conversation pretty much goes almost the same as we've already seen 2 times now. They say hello, and then there's a tiny change because the transport agent passes each recipient as a separate statement, and the delivery agent either accepts that message, that address, or rejects it immediately. There's no queuing here. So if a recipient does not exist, it will say, well, no such user. I can't deliver it to that one. But that's pretty much almost all of the difference. We don't need to go into any details here. A question?
Why would the MTA care if a recipient is there? Does he have to return the message? Or?
Because if you cannot deliver the message to a recipient that's not there, you have to send a bounce and inform the sending message mail transport agent of this is not possible. So you get an error message back. And yeah, the delivery agent is sitting there and waiting until our recipient comes with their mail user agent and starts collecting their messages. We're closing to the end of the game. There's usually IMAP these days in use. the Internet Message Access Protocol. That one keeps your delivery agent state of your emails and the client state of the emails in sync. They update their changes, and it's also convenient if you need to access your email from multiple clients, like your phone, your tablet, your computer, or whatever you may be using, your fridge. Obscure things use email these days. There's also another protocol. It's still in use, and there's some good use cases for it. It's called POP, the Post Office Protocol, and that one's even simpler. Client comes, says, give me all the messages, and then you never talk about it again. The server does not know what the client does with the messages. But it's still in use. We don't want to go into details. They're both about 100 RFCs themselves, so that's probably 7 separate talks. I'll not go into that. And now we have message delivery from a sender to a recipient. Let's have a look what is on a server of all these communicating parts of this large puzzle game. Since passing a message one way is pretty much the same as passing it the other way, we can reverse that. And we end up a mail server very basically being this. You have a transport agent that accepts incoming messages and delivers outgoing messages. We have a submission agent that accepts messages from a client and a delivery agent that keeps messages for a client. And that's usually your postfix dovecot or XIM Cyrus combination on a box. For small email systems, that's a single machine. On larger systems, these parts may be spread across multiple VMs or even hardware. What else do you need to run a modern email system? Because if you put that on the internet, you will be receiving a lot of email. And at some point, your primary reproductive organs have been enlarged enough that you won't accept any more of these because you'll only receive spam mostly. So there's a lot of things more you need to have a fully fledged email system because your users will come up with ideas and annoy you. What do you need? You need some common email addresses. Some are required, like having a postmaster at your domain email address. Because if somebody needs to contact the person running that email system, they use the postmaster address. That's the standard to use. You also need an abuse address if some of your clients start spamming strange things. You want to have an email address to contact and tell them, well, this one is spamming stuff. Can you please make them stop and look at this? And there's a bunch of other ones. I highly recommend also implementing a security at email address that is actually read by human beings at your domain. Because if somebody stumbles across a security problem with any of your systems, please make it easy for them to tell you, because some people will actually do that and be fine with it and not exploit you. So make it easy for them to tell you about this. You'll benefit from this, and it's easy to do. What else do we need? We already had the MX record for the domain name system that tells other systems where they can find a mail exchanger. They will either look up an MX record. If no MX record does exist for a domain, they will fall back and trying an A record or quad A record, which means they will probably try talking to your web server, which usually does not accept email. But it's a piece of the SMTP standard, how to handle this, and this is what they'll try. There's other things you can put into DNS to make your message delivery more convenient. There's the so-called Sender Policy Framework, SPF. Since you can look up where to send email, but there's no way to find out if that server that's sending you email is actually legit and allowed to send email for that domain. So people came up with SPF, and you can put your sending email servers into that DNS record. It's a simple text record. It says, I'm an SPF record. Any box that has an MX record for my domain is allowed to send email, and that one legacy IP and that one IP subnet is allowed to send email with at my domain. And you put that on the internet, and you have a policy part that is the -all, -all, which means, and any other system on the internet is not one of the ones I'm allowing to send email. You could put a plus in there, which means these ones I know about and everybody else is allowed, so that's pretty useless. I would not do that. And there's also the tilde, or the wiggly line, which means there might be others I have not yet discovered, don't care too much about it. That's also pretty useless. So please think about which systems send email for your things and put a dash all in it. SPF has side effects, especially if you're running email mailing list servers or if you forward a lot of email, because that from address you forward is probably not one of your own mail systems, and the receiving mail server checks that and sees, well, these don't match up, and now we're running into a conflict with your SPF record because that says not one of yours, somebody else's, and they may tag your email as spam, even if you only forward it. And that's correct. If it wasn't that way, SPF would be completely useless at all, and we would not need it. So people came up with some solution, which is called the sender rewriting scheme, where your email server will rewrite the envelope of an email so that it matches your own SPF record for your own mail system, and that problem is solved. So if you publish SPF records, you're giving others a hint that your mail system is legit and others are not. And if you forward email, you need other mail servers to implement sender rewriting scheme. Getting kind of a problem. So if you put up SPF records for your own domain, please also implement sender rewriting on your own system. Others will benefit from it. And if everybody does it, we're all happy. Of course, we're not. It's the internet. What else can you do to make your email look more legit to other mail systems? There's the domain key identified email, DKIM, where you have a little more work to do to implement it. DKIM tells your email server to digitally sign with an RSA key that's different from your TLS setup, to sign email that is outgoing. So this is a digital signature done by your mail server that signs that it has passed through one of your email systems. You also need to come up with a string called the selector in this case. It's just a basic text string, 7-bit ASCII in this case. You're limited to that. And an SPF DNS record, which connects all these parts. The fruity Unix is my selector for my domain. Then you have the ._domain key .MacLemon.at or .your domain. Where do you know the selector from? Because you need to look up that DNS record. Well, the selector comes with the email you receive, so you just take it from there. And the rest of the record just says, I'm a DKIM record, I'm using these hash functions. My key type is RSA. The T = S means I'm in production, this is not a testing setup, and it's valid for email. And the part after the P means it's the public key in base 64. And that's a lot of base 64 public key gibberish. You'll have all kinds of fun with that. The benefits of setting up DKIM is that other email servers can identify your email as legit and give it less spam points, which is good for your email because it ends up in the inbox and not in the spam. The drawbacks are you need to have some plugin on your mail transport agent to sign outgoing messages. And if your incoming email should be checked for DKIM signatures to verify, which I highly recommend, you also need some plugin to do that. Conveniently, most plugins that do DKIM can do it in both ways. And since you have to publish a text record in DNS, and if you're using RSA keys larger than 1024 bits, 2048 is the absolute minimum you should use. I recommend 4096 as usual. You get very long public keys, which means you get very long DNS records. And most web interfaces to manage DNS are like really, really terrible when it comes to multi-line DNS records, which are totally valid, but they will silently cut it off at some point, or they will start, oh, there's quotes in there, I'll need to escape those and put backslashes in front of them, and all kinds of weird things. Please open tickets with your DNS providers, though they fix that shit, because DKIM really helps us deliver email better. So far you're announcing which system are sending for you, you're announcing how to verify that a message actually passed one of your systems with the signature by publishing the public key to that. But what should a receiving mail system do with the message that's come from your domain? There's DMARC, the domain-based message authentication, reporting, and conformance. And that one connects these things. If you're either using SPF or DKIM or both, there's no requirement to use them all together. I highly recommend using DMARC anyway, because that adds reporting. So a receiving mail system can report to you, hey, I've received a message from some IP that claims to be you, but that does not match up. Here's what I got. You probably have guessed it. There's a DNS record for that. I silently sneaked the DNS talk into this. And it's always _dmarc.yourdomain. It says, well, I'm a DMARC record, and it has a policy that can be either none, do nothing with it, just look at it, keep an eye on it, but I don't recommend doing anything with it. It can be quarantine, which means make it likely spam, or outright reject it at all. If it has not been signed by my system, don't use it. It's not legit. And then you have the RUA and RUF fields, which means where to send aggregate reports and forensic reports. And you can specify the format and how much percentage of your emails should be checked. Usually you use 100 when you're in production, and how often you would like to receive these reports. 86,400 seconds is usually in Central and Western Europe good for 363 days a year, because there's one with an hour more and one with an hour less. You'll receive a report nonetheless. And that gives receiving email systems a policy on how to act on emails that fail a verification with SPF or DKIM or both, and handle them as spam or not, and give you a report on how often that happens. Since you also have a policy for subdomains, and our domain name system is not entirely clear. There's the so-called public suffix list. It's an initiative originally started by Mozilla. It's now a community-maintained project, and it keeps a list of separating domain names with organizing entities. Meaning Balkan.org, that's simple. .org is the top-level domain, and Balkan is the domain, and mail.balkan.org, mail would be the host name. But what about company.co.uk? .co is not a host, or is not really a domain. UK is certainly a country top-level domain. So this is not entirely clear, and the semantics are not technically there for humans to understand, but not for systems. So this public suffix list will actually connect these things so that your mail system can correctly manage these domain separators. What are the benefits of running DMARC? Well, other mail systems get an idea and a suggestion on how to deal with your emails, or emails that claim to come from you. And when, for example, an SPF and a DKIM record check verifies as okay, that's a strong indicator that this email is coming from a legit system and it's a legit email. And you also get reports that you have to read. That's the drawbacks. You have to read these things. There's also several companies and tools available that make automated things to give you a nice report with charts and everything, so you get a good overview what's happening outside on the internet with systems claiming to send email for you. You might even discover a machine that's legitimately sending email for your domain that you have forgotten that's still out there. So what does our email system now look like? You remember the small thingy with the 3 pieces? Well, we've ended up here now. We're signing DKIM, we're verifying DKIM, we got SPF records on the DNS, we're verifying that incoming as well. We have the sender rewriting scheme, so forwarding email works. We have DMARC, and we're regularly polling the public suffix list and downloading that one. So your mail server now needs to talk to web servers as well. Getting a little more complicated now. But still, it's okay. It's a few pieces, add-ons for your transport agent, and a few DNS records, and a little key handling, but it's all quite okay. Then we need TLS. It's contemporary. Let's Encrypt makes it easy, makes it free to use. So what do you need for that? You need something to deliver an ACME challenge, so the handling of that you're proving that you're allowed to get these certificates. If you want to use certbot by the EFF, or if you're running dehydrated, which is my personal favorite to use, it works very reliable to get your certificates. Works fine on any BSD or Linux system. So you need certificates. What are the benefits of TLS? Well, you don't leak any username and password credentials when people send or receive email. That's quite handy. You also don't leak message content on these parts. And the drawbacks are, well, you have to maintain it. You have to make sure that your certificates are regularly updated and replaced, and that your mail transport agent and delivery agent also loads in the new certificates from time to time because they change. So you can happily be replacing certificates and forget to restart your postfix or Dovecot, and they will use the old certificate, and well, it has been replaced, it's fine. No, just give them a kick once in a while and it will be fine. And since email sending between transport agents over SMTP is opportunistic, well, we don't get a lot of security or privacy there. It's purely hoping that it works, and nobody checks certificates anyway, so at least we can secure the client connections, but that's better than nothing. So now you have some kind of web server, because you need to deliver ACME challenges. That needs a web server. Of course, you can do that with like 2 lines of Python, but well, Nginx or an Apache, it's easy to use, and we might use it for something else in the future. Who knows? Users come up with ideas. So now you're managing certificates and a web server as well. Then your users come and say, well, I'd like to filter my email and sort them into mailboxes probably. So you say, well, you can do that with Sieve on a server, because they come with their phone, does not have a rule system to pass messages around. And what do people use Sieve for? Sorting mailing lists. That's probably pretty common for us. Like you get a mailing list and sort it into a folder and let it rot there and look at it every 2 months and, oh, I missed that one, yeah. Then people automatically forward email to other people. Also happens. But there's one thing, and to be honest, that's the only thing people really use and that absolutely has to work. And that is the out-of-office reply when they go on holidays. Especially if you're running a mail system for a company. If that does not work, you will get phone calls at probably 6 in the morning. Very inconvenient. Another benefit for you as a postmaster is that you can integrate that with your spam system, and once a user moves a message to the junk folder, you can tell Sieve it should take that message, hand it over to your junk, your spam filter, and oh, learn this as spam. And if somebody takes out a message of the junk folder and puts it somewhere else, it's probably not a spam message. Sieve can take that message, pass it on to the spam filter, and please learn this as ham, as a good email. So you can abuse your users to train your spam filter, which is quite convenient as well. So your mail system looks like this. You now have Sieve. It integrates with the delivery agent side of your system. So far, so good. How do you manage these rules? There's a protocol for it. It's called Manage Sieve. You need an interface for it. Users are usually not happy with having the Thunderbird with a plugin where they have to edit code. Some of you may be happy with that, most are not. They would just want to click, I'm on holiday, fuck you. So most email clients do not have some plugin to use. So, okay, let's go with the webmail interface. I mean, it's easy. There's nice solutions out there, for example, Roundcube or Rainloop. They look nice, they work on phones, they're pretty accessible these days, they're free, they're open source. They're pretty regularly patched, so that's fine. You already have a web server because you were thinking ahead when implementing your Let's Encrypt certificate handling. And Roundcube's fine. It's got a lot of plugins available for the future, maybe. Let's go with that. So now you have a webmail interface. You're running PHP on your server. And, well, the web server was there anyway, so it's not that hard. You knew it would come in handy. Then your users start complaining about getting spam. I don't know why. They receive it. There's some cheap tricks to let in less spam to your system. For example, there's block lists. They come via DNS. And your mail server incoming checks if the sending mail server is on one of those block lists and says, well, you look suspicious. I don't like it. Go away. I can recommend zen.spamhaus.org for this. They have a pretty good list that catches a lot of crap, and especially if you're on the European continent, there's a project by German Heise Verlag and the EX magazine. It's called Nix Spam. That block list works a little different. It automatically puts mail servers up on that list, and it automatically ages them out after a few hours unless they keep sending spam. So if you end up on that list for by accident, it's easy to get removed because you can just submit a web form and say remove, and you're instantly gone. And it catches a lot of spam servers and systems in Europe, especially Germany, Austria, Switzerland, in the German-speaking parts of Europe. So that one is a very nice thing, and it has almost no side effects. It's a really nice one. Then there's this thing called gray listing. I don't mind if you prefer the English or the US American way to write it so that regex matches. The idea is that a proper mail system is quite resilient when it comes to sending emails, so it will try again if the mail system is not available. And usually a spam canon will not. So you say, well, new email, no, not now, come again later, and a legit email system will do that. Spammers will not. The problem is with large mail clusters. They send an email, they get a ticket, you're gray listed, they come back from the next cluster node, I don't know you, you get a ticket. Next cluster node comes, just retry and send the email, I don't know you, you get a ticket. And after 6 hours, that Gmail cluster is rotated through and will send an email. Your users don't like these delays. They sometimes happen. So what can we do about it? We'll see. You can whitelist them, meaning you'll maintain a list of servers from Gmail, Outlook.com, whatever large company, and you say, well, they probably have their shit together. I'll allow to send them anyway. So your system looks like this. You're now gray listing, you have DNS whitelists, you have DNS block lists. It's becoming more and more complicated. You're maintaining automated lists, you're maintaining human-maintained lists by manually writing IP addresses and host names into files. Does not sound too nice. Then there's spam, the more expensive countermeasures. There's the so-called Little Shop of Horrors. It's a quite common implementation to combat spam. It's Imavis New, Spam Assassin, and Razor or Pizer. They're Perl monsters. They come with a lot of modules in Perl, and once you update one module, 3 others break. That's quite a common scenario. Every postmaster has encountered that. And they usually are slow. They catch quite a lot, but they're slow, and they cost a lot of CPU cycles, and might take an email to be filtered like 1 second, 2 seconds, 3 seconds. That's quite a lot on a mail system that has a lot of traffic. A more modern solution that I can quite recommend is rspamd. It's a BSD licensed thing written in C and assembler that already sounds faster than Perl. And it's nicely integrated because it can handle these gray list thingies on demand. So it will not gray list any message, but it will check an incoming message. And if it looks spammy, it might delay it by gray listing it. And if it does not look spammy, it will not gray list. So that's how you handle these delays. You'll get rid of them pretty much completely. That's a very nice thing. rspamd also checks your SPF, DKIM, DMARC things, and also aggregates reports and sends them out for you. So that's a very functional thing. And If you want more performance, you can add a Redis cache to it that is used by it. And if you don't get along with one spam filtering system, you can add multiple and cluster them and have a proxy that handles that all for you. So your mail system now looks like this. You have an RSpamD cluster with real-time block listing, gray listing, and a Redis cache. Then some of your users receive malware. You want to get rid of that. Common solution for that is to use ClamAV and ClamD. The standard rule set that comes with it is about 20 to 30% detection rate, which is funny. There's the ClamAV unofficial signature set. It's available as a package for BSD and Linux systems, and it integrates also with RSpamD, so your RSpamD can on demand check for malware. And if you integrate the unofficial signatures, you'll also get definitions by Sane Security, by Securite Info, Malware Patrol, and OITC. And now suddenly that boring ClamAV thing has a really good detection rate, even for newer stuff. And they're free, and just please use them. And now your mail system looks like this. You've added AV and some cron jobs that download these definitions automatically and integrate them with your ClamAV. Since many of these components already try to use DNS, you're hitting your DNS server of your ISP quite hard, especially RSpamD. You have some latency for each of the DNS requests. Some may fail. That has a timeout and takes time. So you add a DNS cache on your local system because that's a lot faster, less packet drops, and now you're managing either a local unbound instance or a DNS mask. But it improves the performance of your system, and you get less rate limiting from your DNS server from the ISP. Then users come back from holiday, they find this nice web interface, turn off the holidays thingies, close it, go on with their phone, search for a message, they want to send something, but they don't find it on their phone because your phone does not have a full index of all the gigabytes of messages they have. What phones could do is pass the search on to the mail server, the delivery agent, and ask it, could you search for this thing in all your messages? And if your IMAP server does support full text search, that actually works, and it works pretty fast, and even with attachments. So you go out there and say, well, there's either Celocene or Apache Solar as a full text indexing plugin that you can hook into your mail delivery agent. Now you're running Java. It works with OpenJDK, so that's a good thing. Yeah, you see, you bolt on things. Then users are, again, using your web interface. They type in an email address or a name, and there's no autocomplete, and they say, why? I've been communicating with them for a long time, and there's contacts. What do we do? Well, there's CartDev. It's an extension to WebDev. It allows you to sync vCards across clients. Your phone probably has one, DevDroid or iOS has one implemented to sync an address book. There's a plugin for Roundcube that can talk CalDev. So it would be convenient to have a CartDev server. So addresses and names are passed across all these agents and users. And then you think, well, there's also calendars, and these fancy calendars can keep events, and you can invite other people to events via email, and they can respond. Wouldn't it be nice to have a calendar server as well? And have my calendar. Some even can look up availability, yeah, and find the most inconvenient spot for you in the morning. So you add a CalDev and CartDev solution that might be Radical 2, or, well, you're looking ahead and might think, oh, there might be other things that these users may want. You're implementing a Nextcloud instance, which is quite okay these days. You're already running PHP for the webmail interface anyway, so PHP is already getting updated regularly by you. Does not matter. You add CartDev, CalDev thingies, add the plugin to your Roundcube, and everyone's happy. But now you need to authenticate against all these systems to log into a web interface, to multiple web interfaces, so you have a problem with authentication. Not all users are using a password manager, still not. And now you want some kind of central authentication instance. You probably have a database server already running because Roundcube uses one, your Nextcloud instance uses one. Dovecot and Postfix can authenticate like a MariaDB, a MySQL, or Postgres instance. Yeah, let's do some single sign-on thingy. So now you're managing one or multiple databases or an LDAP server for authentication. Then you want to host multiple domains, and you have friends. You're running a mail system. You're doing that really well. It's awesome to use your email system. Can't you host my emails for these 3 domains as well? Yeah, sure, okay, it's just 3 domains, doesn't matter anymore. But they want to add users and aliases themselves. So you want to delegate handling of their email domain to them. Now you add a web interface to add email addresses and maybe even email domains to your system. And if you're running LDAP, you have like a LAM interface that can put users and email addresses and aliases and all that stuff into LDAP on your system. So yeah, you're adding an admin GUI to your Frankenstein monster. And then these people come again with their phone and say, well, I can now search for messages. That is awesome. But I don't get notified when I get an answer. I want push notifications. This is the part where you start screaming and say, no, please. There's no real standard across multiple platforms. Of course, there's IMAP idle, which is kind of pushy, but only if you already have a connection that's up and running and that drains your battery on the phone. It's not really an issue for laptops, but it's an issue with routers that cap and cut off more or less unused, long-living connections, and IMAP idle is pretty much an open socket. It's just sitting there and doing nothing. So your firewall will say, well, that state is not used. Bing. And you need to re-authenticate. There are macOS mail systems that integrate with Apple Push to iPhones, like real push messages. These have been reverse engineered to have some weird plugin to your Dovecot email that actually you're receiving mail delivery agent sends out a push message that is received by an iPhone. There's probably solutions with Google Cloud Services to have the same thing with Android. I don't know about these things. They may be available. And then there's these weird email applications that leak your credentials to some cloud service that pulse your email box, and when they receive an email, they send you a push message. One candidate for this is Microsoft Outlook. They will happily use your username and password in the clear somewhere in the United States in the cloud and do that. So now you have a security problem as well and need to somehow keep your user agents tied together. Well, you've added push. There's still some space left somewhere to do that. Now you get new people into your organization or company, and they heard about this awesome system that does contacts and calendars and email and fights spam like the heroes. And they want to have all their devices configured, and they come with their phone, their tablet, a laptop. They have a desktop at the office, and all of these needs to be configured. Yeah, but as an admin, you don't want it. Oh, come on, the 7th email box for you, really? So you want service auto discovery, so that you just email address, password, return, and the email client automatically discovers where to talk to, which email is sent via which server, your submission agents, your delivery agents, everything should be automatically, including the calendar. Yeah. There's different things for mail user agent autoconfig. There is RFC 6186. That would be convenient, but nobody implements it. There's a proprietary solution by Apple. There's one by Mozilla. There's a third one by Microsoft, which is the most sane of them all at the moment. Yep. They usually involve adding some DNS records and serving some well-known files, like in this .well-known folder, and then there's some magic text file they can use. So you end up implementing all 3 because you have a highly mixed client landscape, and now you have 3 auto discovery systems to maintain. And of course, you want the same for CardDAV and CalDAV clients as well, so they can find these. You're lucky in this case, there's RFC 6764, which tells you, oh, just implement these for SRV records in DNS again. And that actually works with most clients, so that's an easy part. There's one thing, and most use that one actually. So there's fine solutions for CardDAV and CalDAV. The benefits is, of course, less support burden with your users. It's faster, it gives them some autonomy in configuring their machines. Less outdated documentation, because the documentation becomes your auto-discovery system. And it can also be used by the not so technically inclined people, which is fine. Sadly, MUT does not support any of these, so that's a drawback, certainly. And of course, for a mixed landscape, you implement it a few times. So yeah, you add discovery there, and now you have SPF, DKIM, DMARC, SRV records, MX, A, Quad A. There's a ton of DNS stuff. You have a cache, it's fast, but is it secure? Probably not, because nobody actually uses DNSSEC, because most people actually can't use it because their DNS provider does not support it. And with Dane, you can actually cryptographically shoot yourself in the foot with a domain. There's even a high score list on the internet for how long somebody has killed a domain to be unusable with the cryptographic sign that it is unusable. And the top rankings are over a year. So please be careful with the key management there if you really add DNSSEC, but it's the only way to secure your DNS where all this magic is already in to support and secure your email transport. Then there's the fraction of I'll not really want to touch. There's of course mailing list servers. They do all kinds of fancy things with forwarding emails, which you run into problem with SPF, with DKIM, with DMARC. So you might want to use MailMan 3, which is the modern mail system. After it's been released since 6 years, so it's probably stable. Not so really. You need to run it from pretty much Git, head, and a few patches, and then you can make it work. But MailMan 3 is great. It comes with MailMan Core that handles all the message passing and DMARC mitigations, and it works with SPF and sender rewriting scheme, which is awesome. But you have no web interface. You need to add Postorius to that. Now you're running Python on your web server as well. And since people would like to look into an archive from 3 years ago, you also need an archiver, which is HyperKitty. Now you have another Django application running on your server. And that integrates all with your postfix and starts configuring things. But at least these things work with a modern setup. Then you might have a support ticket system, something like RT or Zamat or whatever. These things receive email, they send email, they fail authentication because they're not supporting that CREM MD5 scheme you would like, but they want plain or login format. So you're reconfiguring your system to allow these authentication schemes. And they add a ton of headers to your system that contain IP addresses of internal systems and other things. So you add filtering of these headers and normalizing that you not leak all your internals with every email you send via your support system. Then marketing comes along and says, well, we've got these 12,347 customers and we would like to send them a newsletter. And they have gotten this list somewhere, which is of course completely GDPR compliant, and some emails for some reason are bounced, and somebody needs to handle that bounces, hopefully not a human. These systems can handle bounces automatically, so they want to retrieve email, but this newsletter system of course does not speak IMAP because it doesn't want to sync and keep the messages, so you're activating POP on your delivery agent that you have not used until now, but the system collects the bounces via POP and delete them on the server, so it actually makes sense to use that. Yeah, and then there's other problems with robo clients that are sending email, but they're probably not a real email system, like a web server that is sending form data. like this PHP form mailer. Still happens on the internet. It just tries to send, and if it passes through, it's fine. If not, poof, it's gone. It does not try to resend. There are services that do not support authentication with email, like cron. It just tries to insert into a queue. There are services that do not support TLS, like cron. There's alerting systems, like cron, or your hardware enclosure for RAID, or your uninterruptible power supply that will like to tell you that on Thursday evening there was a slight fluctuation in 50 hertz power, and it has compensated for that, which is nice. That's what I have it for. Another email. And some people even do machine-to-machine communication via email. I don't know why, but these things are real. And you probably can come up with a lot of novelties in that regard of systems that are not mail systems that are sending email. So, sneak peek into the future, very brief. What is your next end boss challenge as a postmaster? There's MTA STS. You know HSTS, which is strict transport security for web servers. This is the same thing pretty much for mail servers. A mail server can announce via, you guessed it, DNS, that you should only talk TLS via SMTP. So you add a DNS record with a timestamp, you add another DNS record that says, well, please send reports when you have problems with my TLS to this email address. If that email address is the same system that it has problems with, you might have problems receiving that report. But it works similar to DMARC, and since mail servers also have to use curl or wget or fetch to get things from the internet, like the public suffix list we already had, well, now they need to pull a text file to get the policy that is in MTA STS. It's a simple text file. It says, well, enforce TLS for this time on this machine. Whoever came up with the draft RFC for this had the wonderful idea of telling us you must use carriage return line feed as line endings for that. So they have a heart for Windows users. They're not using Unix endings. So you know how to use Vim and configure that to properly make carriage return line feed endings now. If not, you'll find out because it won't work otherwise. The benefits of this more or less downgrade resistance for SMTP, which is a great thing with StarTLS. And since you're using Let's Encrypt, you already have valid certificates, which is also nice. And it's explicitly designed to work with DANE, so it won't interfere with your DNSSEC record and TLSA records. That's an explicit design goal, so somebody put some good thought into that. Of course, it has drawbacks. There's more DNS records to maintain, more files to put up on web servers that have to hopefully not interfere with how your CMS works on your website. And now you have a web server that you also must secure with HTTPS and HSTS, hopefully HSTS preload as well, and all kinds of security headers that you're already using to secure your webmail interface. Then there's another effort by the EFF. It's called StarTLS Everywhere. It's like HTTPS Everywhere for the browser. It's basically your preload list for mail servers. The EFF has put some thought into it and digitally signs that list with GPG. So now your mail server has to retrieve a text file over HTTPS and GPG verify that. You already had GPG on your clients. Isn't it wonderful? Your server uses it well. Great. What else is there? If you're running mailing lists, especially nice authenticated received chain, you're already signing your outgoing email via DKIM, and a receiving mail server checks that signature, and when it forwards it, that signature breaks because it maybe adds, this is the mailing list footer and you can unsubscribe here, and this is the how-to and all that stuff. That breaks the signature. So a receiving system of the forwarded email will have a problem. Authenticated received chain keeps all those message systems that pass on the message multiple times and keeps those DKIM signatures intact so that you can, it's a linked list of hashes. I don't say the B word. But it helps to keep an eye on who passed on this message and verify that it's all been okay. So that's roughly what you ended up with as a mail system now. You're pretty much running every programming language on the planet. There's certainly Perl, PHP, Python, Ruby, C, C++, assembler. There's shell script, there's cron script, data betas, there's crypto all over the place. There's probably some brainfuck and COBOL in there. I'm not sure, but I would not be surprised. So in conclusion, just sending and delivering email is pretty easy. Having a mail system that actually survives the internet and survives your user support calls is a lot of work, like a real lot of work. Keeping everything running smooth, keeping it updated, not having some update here break something else there. That's also a lot of work. And if you hate email now, like I do, and hopefully I've made myself clear why you can really hate email, I have a solution. It's called RFC 7505. It's a DNS record. You probably have suspected that. It's in bind format. It says, well, there's a mail exchanger. Its priority is 0, which is it's the most important mail exchanger for this system. And you can reach it at a domain that's called .dot, which is the toppest level of DNS. The nice thing is that's a valid DNS record. Any mail system can try to resolve that. It will think it's important, and it will be unable to resolve .dot. So it will never find a way to deliver email. This is really the one way to tell this email does never accept this domain does never accept email at all. Never. Don't even try. There is no such thing.
Excuse me, special delivery.
Oh, that's the vodka. Thank you. Are there any questions left now? Okay, we need to be quick because I'm already over time.
You missed two important services. One of them is the web key directory for PGP, so that would be another web service to bolt on.
For supporting clients when they want to do end-to-end encryption?
Public PGP key discovery through HTTPS for mail delivery.
Yeah.
And of course, what
clients.
about the all-important fax gateway?
Fax gateway.
I missed that.
Yeah. I don't miss fax either. But yes, please do a lightning talk on that next year.
Hi, excellent presentation. You covered like 97% of my own mail server. So, one comment. You didn't mention about the PTR, the importance of having your PTR on your IPs
Yes.
delegated correctly, so the recipients can verify your mail server.
Yes, you absolutely spotted that correctly. I blatantly overlooked to manage another DNS record that you need. Your mail exchanger has a host name that points to an IP, but you also need a pointer, a PTR record, that the IP address points back to that host name. And please don't forget there's a PTR for A records, meaning legacy IP, and for quad A records for IP. So you need two of them. Absolutely correct. They were not in there. Thank you. One last question, okay?
Yeah, a small question. You said that you have users who actually want a web archive for your mailing lists.
Yeah.
Have you any sensible solution to be GDPR compliant if somebody decides that he sent the mail and he now wants to delete it?
GDPR. Well, if you're the case with GDPR is not that you're not allowed to keep an archive. You just need to be transparent about it that you do this. If you don't want your emails to end up in an archive, don't send email. It's all about informed consent. And the GDPR also mandates if a user removes that consent and wants you to delete the things you have, that you must follow that as far as you can. But if that is technically not possible, or if it's an very extreme overburden for you to follow that request, you are allowed to refuse it. That includes a right to complain for the citizen with your authorities, with the so-called Aufsichtsbehörde in German, I don't know what it's in English. Oversight body, yeah. They're allowed to complain there. But you probably don't want to go there and start deleting email messages that break threads. So that would be considered way too much burden to actually follow for not much gain. So you can probably relatively easily handle that.
So one more thing, do you have a Docker compose for everything?
I certainly don't. I run BSD. Thank you very much. Voilà.